I'll begin this afternoon's session with a brief introduction. Welcome to the Canadian Institute of Forestry's National Electronic Lecture Program. My name is Sharon Young, and I will be hosting today's session. Today is Tuesday, February 25th, 2025, and this is a fourth session in the e-lecture series entitled Advances in Operational Forestry, Tree Planting, and Carbon Mitigation Research. The series is a collaborative effort coordinated between the Canadian Forest Service and the Canadian Council of Forest Ministers. The CIF-IFC is very pleased to collaborate and host these webinars. For today's session, we are pleased to have Matt Angus, who will give an exciting presentation titled An Estimate of Wind Disturbance Impacts to Forest Carbon and Wood Supply on PEI. To kick things off, Matt has been doing forest inventory and remote sensing analysis for PEI since moving from a silviculture career in 2019. Working from Charlottetown, Matt leads a continuous forest inventory and permanent sample plot programs for the province while contributing to multiple national forestry initiatives. His recent achievements include province-wide wood supply and carbon budget modeling analysis presented in a State of the Forest report, as well as a supplementary disturbance analysis report in 2024. With that, I will now pass it over to Matt. Over to you.
Perfect. Thank you. Great introduction there. Leads us right into it. So yes, my name is Matt Angus, and I work for the PEI Department of Environment, Energy, and Climate Action as a forest inventory analyst. And today I'm going to be presenting some of the recent work we've done on, you guessed it, the effects of wind on our PEI forests. Specifically a major event that happened just a couple of years ago and its effects on our wood supply moving forward. Yes, on September 24th, 2022, one of the strongest storms that's ever hit the area had rolled through and hit PEI as well. We had winds up to 170 kilometers an hour, 180 mils of rain in just a couple of hours, or sorry, a couple of days. Essentially everyone on the province was without power for a couple of days up to a few weeks. No cell coverage, no data for a few days. Major storm surge causing localized flooding and a lot of extra coastal erosion, which we're always dealing with. So after the immediate kind of emergency was alleviated, things starting to dry out, we got back to work, and some of the longer term impacts became evident, and we needed to start estimating what was happening there. And for me, that involved what was going on in our forests and how damaged could they have been. The timing of all of this was interesting because I was still in the process of delivering a report on our full forest inventory, which was done in 2020, collected all the aerial photography, interpretation, LiDAR, and ground plots associated with that, coming up with the report. And before it was even completed, we had this major event that affected pretty much every aspect of that report. But I kept my head down and I finished what I was doing with that, and then instantly turned focus to try and see what changes to our inventory were needed after this event. This project involved 5 major components, all of which were first-time things for us in the province and me personally. They involved a full satellite acquisition of the province post-storm, so that's tasking a satellite, getting those images, all the contract negotiations involved with that. We then used those images to conduct some automated segmentation and classifications, something we hadn't done before. Took that product, looked at what my most recent inventory said was in all of these areas that were affected, take those compositions and try to update our wood supply. And taking that one step farther, I was able to also simulate the effects to our carbon budget. Timeline across the top there just shows how tight all of this was. But now that it's done, it seems like it's been done for a long time. So the first step was to get new satellite imagery of the entire province. So we are very familiar with aerial photography. It's how we've always done things. This would be the first time that we tried to get satellite imagery across the province. And you can see the final delivery results here in 16 very different looking packages. This took a couple of months of negotiations back and forth with the vendor to get even to this point. And some of the details of the contract can be seen there. 4-band, 50 centimeter pixels. We had to have some of it redone because of clouds and some other issues that came. But finally, last summer, we were able to get a final package, ortho-mosaicked it all together, and finally delivered. Originally, we had wanted to try to do a change detection between the new acquisitions and the aerial imagery that we just got in 2020. But you can see the spectral differences here made that too difficult for us under the timeline that we were under. So we went with a semi-automated procedure to segment these images to try to find the blowdown. This was done with Trimble's eCognition software and their object-based image analysis. So it involves, for those 16 different packages, we had to come up with pretty much 16 different training packages for the model. And essentially all we had to do was find thousands of points that were standing trees and a whole bunch that were already fallen trees, like you can see in the photos there, and then filled in the blanks with some that are classified as forest but may not have trees on them currently. Feed all of that into the software, and with a lot of finesse and finicking with the little parameters that you can do in the software, we were able to finally get some quality polygons output by the model. And we can see that a couple quick examples on the final results here. Red lines showing what the model output as wind affected. So we can see lots of blowdown there. Some pretty obvious patches here as well, next to some areas of still standing. And so yeah, it draws pretty detailed lines around most of it. So next step we finally got a full output of the entire province. Initially, the model had output around 32,000 hectares of the forest affected. We found quite a number of false positives in there, mainly due to the time of year that the images were taken, it being in later fall after a major event. So there was a lot of just leaf off condition that our model was picking up as wind affected. So we spent a lot of time panning around, but using the output as kind of a base to do some manual work. And panning around tens of thousands of hectares across the entire province, we got it to a final product that we were pretty happy with, of 24,000 hectares affected by this storm. That's about 9% of our entire forest, and we say affected because the level of damage was very much a spectrum. Some stands completely flattened, uprooted on their sides. Some with half the trees are knocked down, the rest are still leaning. Some just have some leaners or broken tops. So it was really a whole lot of different types of damage. We didn't have the sensitivity to pull out those different levels, so we lumped them all in together as what we called affected area. The next step was then to see if I could find any trends in what was affected. Were there any forest communities or locations or stand types that may have been more or less affected than others? And after I did that by comparing what was in the wind affected area to what was in our full forest inventory and try to find outliers and things that didn't agree. And long story short, there were really no smoking gun there, no no types that were very obviously more affected than others. I put some of the quick results there. We did see some hardwood was slightly more affected than we would have expected. I think there's still quite a few false positives in there where it was calling it wind affected when it was just hardwoods without leaves. And our conifer plantations were not as affected as our inventory would have indicated them to be. So all in all, the storm affected pretty much all stand types, all ages, pretty uniform, not uniformly, but distributed regularly as you'd expect. So finally, I had got all of that completed. We now had a full distribution of what we estimated to be affected by the storm. So I had all the stand types, how much of each was affected, the different age classes affected. And I was then able to turn that and simulate it through our wood supply software, Ramsoft's Woodsock. So I had just done a full wood supply analysis in 2020 of our inventory, forecasting that out under various harvest scenarios out over 100 years. So I was able to reuse most of that model, but just inputting a new storm event in the first period. So that's what I tried to do with this. So the biggest thing that I had to do was to simulate that event. I wanted it to affect the appropriate stands, the appropriate ages, and beyond that, what happens to those stands after they're affected is the biggest thing. We don't have a whole lot of data on what comes back after these stands, but we made lots of educated guesses with all the local knowledge we could gather, and it involved quite a lot of transitions delays. As these stands are blown over, if you can imagine a full spruce stand blown over on its side, it's going to take a number of years for that to regenerate, and it's probably not going to come back with what it was before. So I built in lots of various transitions to simulate just that broad spectrum of results of what it's going to transition to. Anyone that's familiar with Woodstock will recognize some of this is just a little bit of the syntax of what we have there. If a certain type of stand is affected, here are some possible regeneration scenarios. So I was able to run all that through, do a simulation, and compare the results. And here are the initial wood supply results out over another 100 years of 4 scenarios now. So the 3 colored ones there are presented in the 2020 State of the Forest report. Those are my regular simulations under different harvest levels. And then added in a green one, which was the same middle harvest level plus a major wind event in the first period. So you can see we hit a huge dip, 25,000 hectares affected, 3 million cubic meters of merchantable volume affected in the first period. And then all the regen rules kick in, and we can see the wood supply pretty level for the next few decades, which to us indicates that our harvest levels and forest growth are going to be very equal at that time. And if we compare it to the red line on there, which is without a storm event, but the same harvest level, we see the natural succession of our forest is predicted in the next couple of decades to start declining as our stands get older. We don't harvest all that much around here, so picking the stands that are oldest and at the state of decline is not necessarily something that happens a whole lot in our harvest regimes here. So we figured by this simulation anyway, the loss of wood that we saw right away is only going to be affected in our wood supply, the gap between the green and the red there, until about 2070, when the natural decline of our forest was going to happen anyway. And the regen that we predict in our Fiona simulation is starting to really catch up at that time. So this results are all presented in a post-Fiona update report. And the next step of all of this was to take the outputs of this Woodstock model. I can make that output a schedule of annual events of which stands get affected and what they turn into. And with a little bit of manipulation, you can get those outputs to be fed into the carbon budget model, CBM CFS3. Some of the steps involved with that were to create those woodstock outputs. We put them into the CBM project, and then we pull it all out again and edit it manually because all of our yields have multiple species and a bunch of other formatting that needs to take place. And then we need to translate all my species and disturbances from the woodstock model that I had to match what is in the carbon budget model. And the main event that I created there did not exist in the carbon budget model as I saw it. So we were able to create a new disturbance in there and have the pool, the carbon pool fluxes mimic as close as I could figure to what we see in the field. This figure here is just figure 1-1 of the user guide of CBM CFS3. It's how the biomass transfers between pools on an annual event, as well as under any disturbance that you do. So I was able to create a new disturbance that I called the wind event. It was stand replacing. In my scenario, I had 70% of the merchantable volume moving right to the medium dead organic matter pool, which I figure is wood sitting on the ground, and all the foliage to the appropriate pool, and then 80% of the rest of the wood moving to those pools, 20% remaining as snags, and 30% of the stem remaining as snags. That was to capture the leaners that are still out there, all the broken tops, and the stands that, you know, weren't necessarily completely wiped out. There's still some remaining volume, but I did have to make it be stand replacing because I couldn't reset the yield curves correctly. Didn't have that. Okay, but after much simulation, much time, much in and out of that program, we were able to get some results that made sense to us. And here are a couple of them straight out of the program. I showed them at full scale here to indicate, and just to let us all know that the results were really not as catastrophic as they kind of looked, as the roadside bias that we all inhibit. We walk by, drive by, we see the trees down. Everyone thinks it's the end of our forest, but these results don't really indicate that as such. The top one is the level of decomposition, with our green line being the wind event simulation, and the blue one being the same harvest levels but without a wind event. So we can see the decomposition is higher in the first few years, but after that we see the natural decline of our forest still contributing dead organic matter that's decomposing. It's adding to that every year. New foliage every year is going down in the original simulation. That is not coming down in the Fiona one because it all came down right away. It has now much younger, so the trees there do not emit as much foliage and litter every year. That's what we're seeing there. And the bottom graph is the net primary productivity, which follows a straight logic there. We now have a much younger forest. It's not pulling as much carbon from the atmosphere. That's the green line being below the blue in that bottom graph. So if we take those two, we convert them to CO2 equivalent and add them together, we get the net CO2 emissions from our forest under these two scenarios. So just disregard the first couple seasons there where it's going up and down. That is just an artifact of stretching 5-year periods out into individual years, but the results are similar. So the blue line shows some a carbon sink of our forest for the next 2 decades before we see that real decline in our forest again, starting to flip it back to be a bit of an emitter. While our green line is the Fiona wind event, where we're seeing heavy source for the next couple of decades before that regen starts to kick into high gear, and net primary productivity rebounds, and we start seeing that to turn into a carbon source again. Again, all simulations, lots of assumptions in here, but I think the real value here is showing that this type of stuff can, we can simulate real life events, and we can stretch them out to look what the long-term effects are going to be to those. So that's about 2 years of work and delivered in about 20 minutes there. So I don't really have much else to present about that, but I'm happy to take some questions about it.
Thank you, Matt. That was a great presentation. Before moving on to the Q&A session, let's take a moment to fill out a post-webinar survey, and I will launch it now. Just a reminder that there are 2 questions, and you may need to scroll down to see the next one. All right, Matt, there's one question for you at this moment. Are you using R to run the models or a different software?
We didn't use R for this one. It was all used through the software. Sorry, the segmentation and the classification was all done through that eCognition, then transferred over to ARC Pro to do our manual edits, and then Woodstock and CBM, I used the regular GUIs that come with those. So we didn't use R for this one.
Thank you, Matt. I think you received some compliments in the chat. Very cool, Matt. Great job.
Thank you, everyone.
All right. Looks like we don't have any more questions at this moment. If anyone has any follow-up questions for Matt, please feel free to reach out to us and we will help you connect with him. And a gentle reminder that this webinar is being recorded and the recording will soon be available on our open access website. All right, there is 2 more questions for you, Matt. Are you using the non-spatial CBM right now? Do you have any plans to shift to the spatial CBM?
So fully non-spatial. Our wood supply through Woodstock is non-spatial at the moment. Mainly because we didn't have really the ages of every stand, so putting them spatially, and we don't do an optimized model either, so knowing where the stands are was not of value to us just yet. But yes, we are now looking at upgrading or evolving our methods to be spatial. So that'll be done at least for our provincial forest. So PEI is 85% privately owned, so we don't really worry about harvest schedules and stuff on the biggest portion of the land base. But in our provincial forest, where we get to choose when and where we harvest, a spatial model makes a lot more sense for that. And so, yeah, moving to that generic CBM at some point makes sense for us.
Thank you, Matt. Next question for you is, did you evaluate how CBM performs at simulating biomass and that what?
We didn't look at I compared, the area affected to the levels of biomass in there, but really just taking the default values built into CBM and just using those and taking that as, the kilograms that it says is what we presented. We didn't go out and weigh any of the stuff.
Thank you, Matt. So if there are no more questions, I would like to bring this session to a close. Thank you all for participating in our CIF electronic lectures. And once again, thank you very much to Matt for the great presentation. Bye, everyone.